All right, so today we are going to learn about stoichiometry, which is kind of a big term for chemistry level 1. What this is going to allow us to do is predict how much products can be produced or how much reactants are needed. An example of this, you need to make or cook for 50 people. You need to figure out how much chicken to buy, or how many potatoes you need, or how much bread you need to feed all of these people. So what you do is you have an end goal, and you need to work backwards to see how many ingredients you need to make the product that you need. I could also work forward. I have this many pieces of bread and this much turkey. How many sandwiches can I make? It allows us to predict that. Now, we're not obviously going to be using sandwiches. In chemistry, we're going to be using elements. And our recipe is going to be a balanced chemical equation. But before we get to this lesson, I do want to quick address how to write a conclusion. So last class, we did our lab. And in our lab, the last question, question number 5, asks you to write a conclusion. Now, what I'm providing you is a frame to write that conclusion. Now, please write your own, but use that frame, the little half sheet, to help you assist you in writing your conclusion, either on another sheet of paper or on your lab. Okay, please do not fill in the blanks and staple your half sheet to the lab. Please write your own. Now, in this scientific conclusion, we are first beginning every conclusion with a purpose. And this goes for every lab conclusion. You always need to state what the purpose of the experiment was, and then discuss what you found, whether it was good or bad, whether it was right or wrong, and that goes into our hypothesis. You also want to analyze what went right and what went wrong, and this includes sources of error, or areas that could be improved, and then what you would recommend for further study. This allows us to summarize our data, which is very important in a scientific conclusion, because another scientist reading it doesn't want to have to go through your whole lab report. They just want to look at the conclusion and figure out what the summary is, figure out the important details without having to go through the whole lab report. So our end goal is to have a college level scientific conclusion, or a scientific lab report, which is what we want in the end. Okay? So my example, which you can use, and also the frame I've provided you to write your own conclusion, begins like this. The purpose of this experiment was to experimentally verify the empirical formula of magnesium chloride. I summarized what we did. Then I went into what I found. I found my data disagreed with the known formula of MgCl2. I determined my ratio of magnesium to chlorine using my data to be 1:4, which disagrees with the 1:2 ratio expected. Now, your data might have agreed or disagreed, and this is the part where I state what I found. Then I go and I analyze what could have possibly went wrong. Now, even if your data was correct, there's still some sources of error. A big thing with sources of error is please do not say, my math is probably wrong. That's an avoidable error that you should go back and fix. Sources of error are things that I can't fix. For example, the disagreement in my experimental data to the known value shows room for improvement. Sources of error could be from the fact that we could not heat to a constant weight due to the lack of time. Time is not something I can control. Therefore, it is a source of error. This could have caused the mass of chlorine to be heavier than it actually was. Also, our balances only had 2 decimal places, which affected the precision of our mole ratio. Balances is something I can't control. Those are 2 sources of error that I can't help that could improve my data. Then I go, what could I do to improve? Or what should I do next? To improve this experiment, more precise balances could be used. Also, additional investigations using various compounds would be a good additional experiment to increase our lab skills collecting quantitative data. I put this all together and I get a scientific conclusion. So what I would like you to do is take 15 or so minutes and work on your lab. And write your own conclusion in number 5 on the back. Once you're done with the lab, put it in the basket, and then after 15 minutes, we'll continue with today's lesson. So take a minute, pause the video, and work on your lab. For today's lesson, we're going to do stoichiometry using the mole method. So everybody should have out handout 7.1 and your guide, your cheat sheet that looks like this. So you have out handout 7.1 and your cheat sheet that looks like this. Okay? Now, this was your cheat sheet from last class that showed us how to convert from grams to moles to liters to particles. And hopefully we got comfortable with that. Because now I'm going to add to that, and we're not only going to go from grams to moles to volume to particles, but we're going to go from substance A to substance B. And that's stoichiometry. Now it's really the same thing except an additional step, this mole to mole bridge, which allows us to go from substance A to substance B. Now this mole to mole bridge that takes us from one substance to another is found using the coefficients from my balanced chemical equation. So we're doing the same thing we did last unit, except this unit we're adding one step going from moles of one substance to moles of another. Okay? For example, in a recipe, you could go from bread to sandwiches. How many pieces of bread does it take to make how many sandwiches? In this case, we're saying how much of substance A does it take to make how much of substance B? And where we get that information is the coefficients from our balanced chemical equation. Now before I get too far ahead, I would like you to add some things on your chart right here to help us in converting from one substance to another. So when I'm going from mass to mole, remember where I'm coming from goes on bottom. So mass is going to go on bottom. So I'm going to put an arrow under mass. What I'm going to is going to go on top. So I'm going to add moles, or an arrow pointing up above moles. I'm going to do the same thing here again. If I'm starting over here, moles is going to go on top, liters is going to go on bottom where I'm coming from, and if I'm starting down here, particles is going to go on bottom, and moles is going to go on top. Okay? Now when I'm going from substance A to substance B, this is going to be a mole ratio, where substance A is going to go on bottom, and substance B is going to go on top. Now this mole ratio is going to come from my balanced chemical equation, and we'll go over some examples of that in just a minute. But after I jump this mole bridge, I'm going to go to mass, volume, or particles. Now if I'm going to mass, now I'm going to mass, so it's going to go on top. Moles is where I'm coming from, it's going to go on bottom. I'm going to add arrows. I'm going to volume, volume is going to go on top. Coming from moles, moles is going to go on bottom. And then I'm going to particles, particles is going to go on top. Coming from moles, moles is going to go on bottom. Okay? So all of these are going to help me convert from substance A to substance B, and that's going to be our goal. So let's look at our note guide and look at our first stoichiometry problem, which allows us to work backwards or forwards, predict how much product can be made or how much reactants I need. So let's begin with our note guide and define stoichiometry, which is the study of relationships of measurable quantities such as mass, volume, and number of particles. We're studying the relationship between these things. And why is it important? Because it allows us to predict the amount of products that will be created or the amount of reactants that are needed to make a specific amount of product. So hopefully you're following along. Again, we're on handout 7.1. Please take a moment and fill in the blanks. Now, what I need to do, or how I do this, is two basic steps. What I always begin with is a balanced chemical equation, which was Unit 5. So if you weren't that good at balancing chemical equations, you'll get some more practice now, and if you need additional assistance, please come see me. But that's going to be step 1, to write a chemical equation and have it balanced. And this chemical equation tells us how many nitrogens we need to react with how many hydrogens to produce how many moles of ammonia. This is ammonia, NH3. So this balanced chemical equation is our recipe. which says for every 1 mole of nitrogen, I need 3 moles of hydrogen to produce 2 moles of NH3 or ammonia. This is going to allow us to go from substance A to substance B. Some of it we can do in our head. For example, if I want to produce 4 moles of NH3, you should think that I would need 6 hydrogens and 2 nitrogens. Or if I wanted 6 NH3s, I would need 9 hydrogens and 3 nitrogens. So this mole ratio allows us to convert from one substance to another. After we have this balanced chemical equation, we're going to use the factor label method to convert from one substance to another. Now this factor label method is something we're all familiar with. Okay? It's something that we did in Unit 1. For example, when I started at 5 days, okay, and I said how many minutes was in 5 days, what I started with was my given, and then I converted. First, if I want to end up over here at minutes, okay, first I went from days to a smaller unit, days to hours, where the unit that I'm coming from, days, going on bottom. So the unit that I'm coming from, days going on bottom, and hours, sorry for my handwriting here, hours going on top. So if I'm going from days to hours, I know 1 day equals 24 hours, and this right here is a conversion factor that I know, okay, that I know, sorry, just give me a minute, so that I know, okay, I know how to go from days to hours with where I'm coming from, going on bottom, where I'm going to, going on top. But again, I'm not done, because I want to go from days to minutes. So now I would go from hours, okay, to minutes. And I know there are 60 minutes, so I'd do 60 minutes in 1 hour. So what I would do here is take my 5 days, that cancels as I go to hours, and I'd multiply to get that to cancel. Then I'd cancel hours and get to minutes. So I'd start with 5, multiply by 24, multiply by 60, and I'd get my answer right here. This is the factor label method that allows me to convert from one substance to another. And we're going to be doing the same thing in stoichiometry. But we're going to be using our balanced chemical equation to do that. So, here's example 1. Our balanced chemical equation is right here. Our starting point is going to be the number that we are given. Okay, our starting point is going to be 3.75 grams of nitrogen. The question asks how many grams of hydrogen, so that's what we're going to. So we're going to start with 3.75 grams of nitrogen, and I want to go to grams of hydrogen. So I'm going to be going from grams of substance A, this is grams of nitrogen, my starting point, to grams of hydrogen. So if I use this map, I'm going to map it out. It's going to be 1, 2, 3 steps. Where first I'm going to go from mass to moles. Now to go from mass to moles, remember with my arrows, molar mass goes on bottom of my starting substance, N2, with 1 mole going on top. Then I want to cross my mole bridge. Now how do I cross my mole bridge? I use the coefficients for my balanced chemical equation. With substance A, my starting point going on bottom, what is the coefficient of substance A? 1, that I got here from my balanced chemical equation. Substance B, what I'm going to, H2, 3 going on top. So that's allowed me to cross my mole bridge. Then I want to go from moles to mass. So 1 mole is going to go on bottom, and my mass of substance B is going to go on top. And this is a stoichiometry problem that takes me from grams of substance A to grams of substance B. Now punching this in my calculator, I divide, multiply, multiply, and I get my answer of 0.811 grams of H2. Take a minute, try to do that in your calculator, try to process it, and we're going to do some more examples in just a minute.